Okay, so today we're going to be writing equations of hyperbolas, and so up here on the board you're going to notice, okay, this is the second part of section 7.3. It says write the equation of the hyperbola. They tell us that the center is at -1, 5, the foci is at 2, 5, and the major axis is 4 units long. Okay, so the center is at -1, 5. All right, so I'm going to go ahead and just draw a quick sketch. So here I am at -1, here I am at 5. So this is where my center is. Okay, they tell me that the foci is at 2, 5. So they tell me the foci will be right here. So in other words, what does that distance tell me? So yeah, 3, but what equals 3? C equals 3. Okay, now the next one, they say that the major axis is 4 units long. Now when we think about 4 units long, how far from the center will one of the vertices be?
2.
2, very good. So here's going to be where one of the vertices is. And so I know that A has to equal 2. Okay, and what direction is it going to open? Left to right. So it's going to open this way. So I know in my equation it's going to be x minus h quantity squared over a squared minus y minus k quantity squared over b squared equals 1. And so all I'm going to do then is plug in what I know. I know that h is -1. I know that k is 5. I know that a is 2. So what do I need to find?
C or B?
B. And so in order to find B, I'm going to have to use the fact that C equals 3. And so if you remember that nifty little formula, what was the formula? A squared plus B squared. Good. Okay, so I know that C squared is 9. A squared is 4. What does B squared have to equal? Now, you don't have to go any further beyond that, because in your formula, you just need B squared. So I need 5. So I can go ahead and write out my formula. My formula should be x plus 1 quantity squared over 4 minus y minus,
Oh, no,
It's
no.
minus.
okay, over squared over 5, and that's going to equal 1. So there you go. So it follows along the same rules that we've already done with parabolas and ellipses. Let's go ahead and look at another one. Okay, we're going to go ahead and look at another one. And then we're going to talk about something known as eccentricity, which is something we've already talked about. So first thing I'm going to do is I'm going to draw a quick sketch. So I know that the center is at 3, -1. So, okay. So 3, -1 puts me right about here. And I know that one of the vertices is at 6, 1. What direction is it going to open? Left and right. Okay. What does this tell me right here? A is 3. Okay. All right, so I've got my nifty little formula. X minus h squared over a squared minus y minus k squared over b squared, and that's going to equal 1. If I fill in what I know that h is 3, I know that k is -1. I know that a is 3 squared, so once again I need to find what b is. So I'm going to use that tidbit of information that they give me. They give me the asymptotes. That's what when it says A, that means asymptotes. And so when I think back to yesterday, if it opened left to right, what was this number? Was it A over B or B over A? It was B over A if it opened left to right. So basically, I know this has to be B over A. Correct? So I know that B over A has to equal 2 over 3. Well, I already know that A is 3. So B has to equal 2. So I've got 2 squared. 2 squared. All I need to do, I'm having trouble with the pen today.
So if A would equal like 6 in that equation, would you double the
Yep.
answer?
You'd have to solve it.
Okay.
And so what you would do, if you said that it equals 6, what you would do then is plug in your 6, and then you could cross multiply and solve. And that brings up a good point because it probably will do that sometime. So over 9 minus y plus 1 over 4, and that's going to equal 1. There we go. Questions? Should be pretty straightforward. All right, determine the eccentricity of the hyperbola. Eccentricity of the hyperbola. What's eccentricity equal? C over A. Good. So that was what we learned when we learned ellipses. Okay, when we learned about ellipses, we learned the eccentricity was how rounded, okay, the ellipse was. And so in my formula here, do I know C or A? A? I know A is what? 8. Okay, so A is 8. Now I got to figure out what that C is. What do I know B is here? We're at 80. So let's use our nifty little formula, and based on the fact we know A and B, we're going to be able to find C. I know that C squared equals A squared, which is 64, plus B squared, which is 80. So C squared is going to equal 144. What does C equal? 12. So let's plug 12 in here. Reduce it down. What's your eccentricity? 3 over 2. So that's all you're going to do. It sounds like it's really confusing and really hard, but it's not. Is that okay? Okay. All right, last thing we're going to cover. We've got one problem like this. The graph of a second degree equation of the form. And so basically, if you want to look at this is in your book. It tells you if b squared minus 4ac is less than 0. A little bit of terminology. Does anybody remember what b squared minus 4ac, what that's called?
It's in that one solving the square formula.
Yeah, it's in the quadratic formula. It's got a special name. Okay, this, I think I've said it.
No.
Discriminant, yep.
Yeah.
Discriminant, and I've said it in passing. Okay, and so the discriminant is b squared minus 4ac. And so based on what you get your discriminant to be, it'll tell you if it's a circle, ellipse, hyperbola, or parabola. First of all, if it's less than 0, it's either a circle or an ellipse. Now, in order for it to be a circle, you can't have b, and a has to equal c. Okay, it's an ellipse if those aren't the cases. If it equals 0, b squared minus 4ac, that is a parabola. And if it is greater than 0, that is a hyperbola. Now, your book has a chart that has all this information on it as well. And that chart is actually found on page 447. So I took all of this off of that chart on page 447. So if you want to go ahead and you can turn in your book to that as well, you can use that. We're going to go ahead and look at an example. Okay, so as I said, you can follow along in the book. It says use the discriminant to identify each conic section. Biggest mistake people make, okay, is they neglect to identify A, B, and C correctly. That's all you need. A is always the coefficient of x squared. B is always the coefficient of what?
Y squared.
No, XP,
XY.
Yeah.
C is always the coefficient of what?
Y squared.
Y squared. So is there an XY here? No, so I know that B has to equal 0. And then this is C. So in this problem, I've got B squared minus 4AC.
Wait, so
B is 0.
B can't equal
Yes, it can. I have 4 times 4 times 3. So what's 4 times 4 times 3? Negative 48, which is less than 0. So if it's less than 0, it can either be a circle or an ellipse. In order for it to be a circle, B has to equal 0, which it does, but also A and C have to be the same. So are A and C the same? Nope, so this is an ellipse.
Wait, it says B can't equal 0 anything else.
Either B can't equal 0 or A equals C. If A cannot equal C. So the key word, if you didn't catch what was said, it says either B doesn't equal 0 or A cannot equal C. So one of the two can exist. It just can't be. Okay, let's look at this next one. Where's A?
2.
2. Where's B?
4.
4. Where's C?
2.
2. Okay. A is the coefficient of x squared. B is the coefficient of xy. C is the coefficient of y squared. So I get B squared minus 4AC. So what is 4 squared? 16 minus 16, which means this is what? Which means it is a parabola.
Should write down this one.
It'd probably be a good idea having it in your notes. All right, let's look at the very last one. I'll be done in a minute. What's A? What's A? 6. What's B? What's C? What's C? -3.
What?
So C is -3. Now how you get that is everything has to be on one side of the equation. And it wasn't on one side to start with, so you needed to move all those over. And that's why by making them negative you can. And so B squared, what's that going to be?
4.
4 minus 4 times 6 times -3. So I end up getting 4 minus -72. So what is that going to be? 76. So that makes this a hyperbola. Biggest mistake people make is they don't put everything on one side and they don't identify A, B, and C correctly. So your assignment, you can go ahead and add, and I believe that I might have given this to you yesterday, but Monday, probably going to have a quiz and worksheet over hyperbolas. Tuesday is the A and C 12, and then Wednesday we're going to continue on with conic sections.